Okay, I have a couple problems from the business world up on the board here. Let's just focus on this one for right now. X is representing the number of products that we're going to make. R of X is the revenue generated by making and selling X products. And then we call R prime, the derivative of that revenue function, the marginal revenue. So what I want you to do in a minute is just pause your video and write down the answer to these three questions. What are the units for the marginal revenue? What are the units we get if we integrate that marginal revenue? And then what does it mean if this integral of the marginal revenue is negative 150? So go ahead and pause the video, see if you can answer those questions. Welcome back. Okay, so for the units for the marginal revenue, if I were plotting revenue, I would have X here and R of X here. X, we said, was the number of products, so the units there are just in products. If R of X is the revenue, that's going to be in dollars. Okay. So the units for R prime, well, R prime is just geometrically a slope, so it's going to be these units divided by these units. So that would just be dollars per product. Okay. Now, if I'm integrating that, now I've got products here, and I would have R prime of X here, and that would be in dollars per product. When I'm integrating, I'm going to multiply those units, because essentially what we're doing, let me clear some space so that I can show that. What we're doing is it's like we're taking area to be a metaphor for whatever it is that we're calculating. So I would be putting X, which was measured in products, as the base of my shapes, and R prime of X, which was measured in dollars per product, as the height of my shapes. And if I'm calculating an area as a base times a height, I'm multiplying. So it would be products times dollars per product. This would just be dollars. Okay. And so then what does it mean if I integrate and I get negative 150? Well, I know now that's negative $150. If this is integrating the rate of change in revenue, this is the amount of change in revenue. This is telling me that my revenue would go down by $150 if I increased production from 100 to 150. In other words, I probably don't want to do that, because I'm going to start to lose money that's coming in. It might be that I'm saturating the market, and so people are willing to spend less for something because there's just not sufficient demand. Okay, so that was our first question. Now, here's the next one. Okay, marginal revenue is given in dollars per 100 products, so be careful with the units here. And it's given by this formula. R prime of X is 2 minus X plus X squared. And I'm asking two questions here. First of all, how much will the revenue change if we increase production from 500 to 600 products? And then, will the revenue increase or decrease if we do this? Okay. So I'm going to suggest again that you pause the video, try to work that out, and then tune back in. Okay, I'm erasing the board while you're pausing, but you might have come back, so welcome back. Okay. So, key thing is that I'm measuring this in dollars per 100 products. So, if I've got R prime of X here, and that's in dollars per 100 products, I'm going to want X to represent not products, but 100 products. So, if I'm making 500 products, I would say that's when X is 5. If I'm making 600 products, that's going to be when X is 6. So that 5 corresponds to 500 products, and that 6 corresponds to 600 products. Okay, and we're asked how much the revenue will change if we increase production from 5 to 6. Well, I'm going to get that, or from 500 to 600, I'm going to get that by just integrating the rate of change. But I'm going to integrate it from 5 to 6 because of the way I'm working with those units. Okay. So we will have the integral from 5 to 6 of 2 minus x plus x squared dx. So that's going to be 2x minus x squared over 2 plus x cubed over 3. And that's all just evaluated between those endpoints. Okay, so I need some space. So I'll erase this. So that's going to be what I get at 6 minus what I get at 5. When I plug in 6, I'm going to get 12. 6 squared is 36. Divided by 2 would be 18, so minus 18. Plus 6 cubed, that's going to be 36 times 6, but then I'm going to divide by 3. So I'm just going to say it's 36 times 6 divided by 3. Oh my goodness, that's 36 times 2. That's 72. Just a nifty shortcut. Okay, I've got to subtract what I get when I plug in 5. So that would be 2 times 5 is 10, minus 25 halves, plus 125 over 3. So let's see. 12 minus 18 is negative 6, plus 72. That's going to be 66. Yes? Yes. Okay. Minus. Now here I probably want to go ahead and get a common denominator. Looks like we're going to want a 6. So this would be 66 minus 75 sixths plus 250 sixths. So that's 66 minus how many sixths? Okay, so 60 minus 75 is going to be negative 15 plus 250, so that's going to be 235 sixths. So let's get ourselves a common denominator here. Right now that 66 is over 1, so I'll multiply by 1 in the form of 6 sixths. Okay, 66 times 6. So I'm getting 396 sixths minus 235 sixths. That is 161 sixths. So that was the answer that we got here. How much will the revenue change if we increase production from 500 to 600 products? And revenue we were measuring in dollars, so it would change by 161 sixths of a dollar. So that's dollars. Okay. And if I'm not sure, I can always get that by saying we were integrating our prime of x, which we were measuring in dollars per 100 products, with respect to x, which we chose to measure in hundreds of products, so that that would cancel and just give us dollars. And then the second part was, will it increase or decrease? Well, is that a positive or a negative number? It's positive, so revenue is going to increase by that amount.